This is the fourth video on Lewis diagrams, and this is on a concept called resonance. Now, if you recall, Lewis diagrams are just models of structural formula, but any model has to be able to fit the data that is presented. If the model and the data do not agree with each other, then the model must be changed. The data cannot be changed. And so I want to go straight to an example where this will demonstrate all of this. So we want to talk about the nitrate ion, and it is observed that the nitrogen-oxygen bonds are all the same length. Draw the Lewis diagrams. Okay, we know how to draw Lewis diagrams. We're going to do it for nitrate. So in drawing the Lewis diagram for nitrate, just a quick reminder, don't forget the 1-. So following the rules, we start out with the NASB, and so there's the table, including the 1 extra electron for the negative charge. Next, we determine the central atom, and we know that nitrate is less electronegative than oxygen by looking at the periodic table, so that's the central atom. Now we write down the central atom and place the other elements around it, like so. Now we're going to put in a single bond between the central atom and all the outer atoms, and we'll take away 2 electrons from the available column per bond. So now we have 18 electrons that need to be placed. We're going to distribute them in pairs around the elements, and there we've used up all 18, and we notice that we don't have enough electrons because the nitrogen does not have an octet. So we're going to slide pairs to form a double bond, and so we're going to pick these 2 and slide them over here, and it looks like that. But we're not quite done yet. We need the brackets in the 1-. Go back to the original question. Please draw the Lewis diagram for nitrate. You go like this, but you have missed something. Notice what the question says. It says the nitrogen-oxygen bonds are the same length. We have a double bond here, we have a single bond here, and a single bond here. And we know that single bonds are not the same length as double bonds. This Lewis diagram does not fit the data. This is a paradox. We use a construct called resonance. Resonance is a model. It's not real life, but it helps us explain. Resonance occurs when you need more than one Lewis diagram in order to demonstrate the equivalence of bonds in the diagram. So you start with this. What you then do is move the double bond to a different oxygen, and then do it again, so you now have 3 Lewis diagrams showing a double bond between all possible oxygens. These are all connected by an arrow. This is called the resonance diagram. What this indicates is that the 3 bonds are equivalent, but they're not quite single bonds, and they're not quite double bonds. When you draw it, you have to show all the resonance forms at the same time. What is tough to understand is the 3 Lewis diagrams do not exist separately. As a matter of fact, they don't really exist at all. This is just a model to try to show that the bonds are between a single and a double bond. It is a construct. Let's try a simple one for you guys. You're going to look at ozone. The bonds are all the same length. Please draw the Lewis diagram. I'm going to give you a hint. You are going to need resonance. And I'll even give you another hint. Oxygen is the central atom. So go, draw it out, come back, and I'll run through it. Go. This is the correct rendition of the Lewis diagrams for ozone. It has to be done in resonance form. Here's the NASB table for ozone. We use oxygen as the central atom. We now can put in 2 single bonds, so we've used 4 electrons. Now there are 14 left to place. You place those 14 electrons. You see that we're missing an octet over here. So we'll take these 2 electrons and slide them over here. And you get something that looks like that. And all 3 oxygens now have an octet. But the bond lengths, because this is a double bond and this is a single bond, are not equal. So I need to show the equivalence. So I have to draw the second form and connect them with an arrow, and this indicates that this is a resonance structure with the bonds shorter than a single bond but bigger than a double bond, but both bonds being equal. You need to practice this. You do have your worksheets. So to review, resonance is a construct to make the model fit the data. It's not real life, but it's the best we can do. It's a model. You're going to need more than one Lewis diagram. Don't forget to connect them by an arrow. And if they're ions, don't forget the brackets and the charge. The bond length will be in between a single and a double bond. The bond length is 1 plus 1 over the number of resonance structures. For example, if you have 2 resonance structures, such as in ozone, you'd say the bond length is 1.5, or it is halfway between a double and a single bond. If you have 3 resonance structures, such as in nitrate, you'd have a bond length of 1.33, or the bond length would be about 1/3 of the normal distance. So that does it for resonance. What you need now is practice, so do the worksheets. In the next video, we're going to discuss what happens when you have more than one correct Lewis diagram for a specific molecule. Which one do you pick?